All right, in this session, I just want to walk you through some projectile motion examples. Now remember, there's no math prereq for this class, so we will keep everything either perfectly vertical, perfectly horizontal, no trig, no angles, anything like that. So it's actually fairly simple. All right, one of the activities we did was walk down the hall and drop the tennis ball into the bucket, and I told you you had to walk at a constant velocity. All right, and you drop that ball from some height, but because the ball has inertia, it keeps going, so you had to let go a little before the bucket. All right, so let's say that an object is launched at 3 meters per second, perfect horizontal, and that is from a height of 2 meters, whoops, equals 2 meters. Get a better equal sign there, from a height of 2 meters, and I want to know how far away it would land. Again, we're going to ignore air resistance and assume that gravity is 9.8 meters per second squared. So we're always going to use that. Anytime there is a vertical in your question, assume you need to account for gravity. Okay, the first rule is find time. Okay, you have to find time. Time does not have a horizontal and a vertical. And remember, we cannot mix our horizontal and vertical. But time does not have a direction. Velocity is a vector quantity, has a direction. Time does not have a direction. So if we look at a formula sheet, if you have a height, you have time by default. You can use this to find time. All right, we've got a height of 2 meters. 1/2 times 9.8 meters per second squared, t squared. Not a very good square there. I'm not writing very well today. All right, so we'd have 2 meters is 1/2 times 9.8 is 4.9 meters per second squared times t squared. We're going to divide meters per second squared, divide, and 2 divided by 4.9 is 0.408 or 0.41. And my meters cross out, so I'm left with second squared. Take the square root of both sides, and my time is 0.6388 or 0.64 seconds. 2 decimal places is plenty. All right, that's my time. Now I need to know the distance. Well, distance is horizontal. Our velocity is horizontal, so we can mix those two and we can use d equals v. D equals VT works really great for average velocity and for constant velocities. So my distance is what I'm looking for. My velocity is 3 meters per second. My time is 0.64 seconds. And remember, I leave it in my calculator. So if my answer is just a little bit different from yours, that is the reason, and I get a distance of 1.9166 or 1.92 meters. All right, that's if we have velocity and height. Let's look at a little different situation. Let's say somebody drives their car off a cliff. Now, I'm not recommending you do this, but we are in a global pandemic, so maybe it is a thought. So you're driving your car at 30 meters per second off a cliff with some height that we don't know, and it lands 100 meters away. All right. Now, still, even though we're looking for height, the first thing we solve for is still time, okay? Now, we can't use h equals 1/2 gt squared because we don't have an h and we don't have a t, so we don't have enough letters, but velocity is horizontal. Our distance is horizontal, so we can say d equals vt. And we can say our 100 meters is equal to our 30 meters per second times time, divide by whatever is in front of the letter. Our meters cross out, that crosses out, and our time is 3.33333333 seconds. All right. Now, to find height, now we can use h equals 1/2 gt squared. And so our h would be 1/2 times our 9.8 meters per second squared, because we're on Earth. Unless I say you're doing projectile motion questions on a different planet, assume we're on Earth. 3.3333 seconds squared. So I'm just going to multiply straight through. So I'm going to take 1/2 times 9.8 times 3.33 squared, and that gives me 54.33 meters. That is a heck of a cliff. 3 meters. All right, now let's go one more scenario. And let's see, we had V and D, we had V and H, so let's do one where we solve for V. Let's say something is launched from a height of 6 meters, okay, and it lands 35 meters away, let's say. How fast was it going? Well, again, the first thing you always solve for is time. So we can use this. Our h is 6 meters. 1/2 times 9.8 meters per second squared. You should be getting good at this one by now. So I am just going to skip over the steps to save time. And I get 1.1065, so I'm going to say 1.11 seconds is my time. I'm going to leave everything in my calculator though. Well, I also know my distance is horizontal, my velocity is horizontal, so I can use this. Now that I have time, time is both horizontal and vertical, so I would have my 35 meters would equal my velocity times my 1.11 seconds, except for me, I'm going to leave it in my calculator, so it's 1.1065, blah, 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 blah. I'm going to divide by what's in, by the letter. And I'm going to be left with a velocity of 31.63 meters per second. And if you rounded, you got 31.53. If you rounded and did the 35 divided by the 1.11 and didn't leave it in your number, you got 31.53 meters per second. Both are close enough.